Today we're going to do practice problems from Algebra 1, Module 1, Lesson 14, Solving Inequalities. Question 1. Find the solution set to each inequality, express the solution in set notation, and graphically on the number line. Alright, so my first problem says 6x plus 2 is less than 7x minus 1. I'm trying to isolate that variable x by using some of the properties that we have already discussed. We discussed that the properties that we use for equations can also be used for inequalities. That is, our commutative, our associative, our distributive, and our additive and our multiplicative properties of equality can be used in inequalities. So what would I want to do first here for this equation? Okay, well I see that I have x's on both sides, so maybe I want to take this 6x and subtract it from this side. And if I subtract the 6x from this side, I'll have to do the same thing here. So let me go ahead and do that. Okay, I'm going to go ahead and subtract 6x from each side. Now once I have the 6x subtracted, it's time to simplify. So 6x minus 6x will make 0, and I'll be left with 2. 7x minus 6x will make 1x, or just plain old x. So simplified, it looks something like this. 2 is less than x minus 1. The next thing I want to do is I want to get rid of that minus 1. Okay, I can use an additive property. By adding 1 to both sides, I will manage to move that 1 over. So then I have 2 plus 1 on one side and negative 1 plus 1 on the other side. Simplifying that, 2 plus 1 will give me 3. Negative 1 plus 1 will cancel. And this is what we have. 3 is less than x. Now we don't want that x in the back, we want the x in the front. So then we have to take the x and we have to flip it around with the 3. Okay, so the x will come in front of the 3. And because the x comes in front of the 3, the inequality symbol also flips at the same time. So I want to express this in set notation. In order to express in set notation, I'm going to need a text box. Okay, I'll go ahead and put one here. We're going to need a brace. My x's are real numbers, such that, okay, we can take a space there, such that x is less than 3. Okay, and we also want to represent that graphically. I'm going to need an open dot at 3. Okay. I'll go ahead and drag one onto my number line. I also want all the x's that are less than 3. Okay. Alright, so I'm going to need an arrow pointing to the left. Okay, to represent the numbers that are less than 3. My next problem, okay, it says x squared plus 2 times x minus 1 is greater than x squared plus 5. Okay, so once again, we're trying to isolate for x. So I notice I have lots of things going on. I have x squareds, I have plain old x's. I notice that there's an x squared on this side and an x squared on this side. So what I want to do is I want to get rid of those x squareds by subtracting them off of both sides. It's going to look something like this. When I do x squared minus x squared, they're going to come off of here. And when I do x squared minus x squared, they're going to come off of here. So when I simplify my equation, it looks something like this. It's going to be 2 times x minus 1 is greater than 5. Now at this point, I can divide both sides by 2. Or I can distribute the 2 into the parentheses. I chose to distribute the 2 into the parentheses. 2 times x will give me 2x. 2 times 1 will give me 2. So at this point, I'm going to go ahead and take this 2, get it away from the x, by adding it to both sides. It's going to look something like this. So then we'll have 2x minus 2 plus 2 is greater than 5 plus 2. Okay. Simplifying that, the minus 2 plus 2 is going to cancel, and the 5 plus 2 is going to make 7. In order to get rid of the 2, I divide both sides by 2, or multiply each side by 1/2, and we're left with x is greater than or equal to 7 over 2, or I went ahead and converted it to the decimal 3.5 to make it easier to graph. Okay, we want to go ahead and put that in set notation. Okay, so I'll go ahead and write that here. Once again, we need to open up our brace and put x real for real numbers. Okay, and we want all x's that are, and get my greater than or equal to sign. And I'll just put 3.5 since I can't type a fraction, so we'll leave that as 3.5. Because it's an exact decimal value, the 7 over 2 or the 3.5 are both acceptable. If that was not an exact decimal value, I couldn't represent it as a decimal. I would have to represent it as the fraction. Okay, so now we're going to represent it graphically on a number line. I need a closed dot this time because 3.5 is a part of my solution set. So 3.5 is in between the 3 and the 4. And I want all numbers that are greater than that. So I'm going to bring me an arrow that shows those numbers that are greater than that. Excuse me there, my arrow is a little large. Let me bring it in. Okay, moving on. Question 2. Question 2. Fergus was absent for today's lesson and asked Mike to explain why the solution of negative 5x is greater than 30 is x is less than negative 6. Mike said, oh, that's easy. When you multiply by a negative, just flip the inequality. Provide a better explanation to Fergus about why the direction of the inequality is reversed. Recall that our multiplicative property of inequality is only for positive numbers. Okay, a is greater than b, and that will be true when I multiply both of those by a constant, so long as that constant is a positive value. It doesn't work for a negative value. So I can't just divide both sides by negative 5 or multiply both sides by negative 1/5. Okay, so what I have to do instead is I have to make that negative 5 into a positive one. So I'm going to go ahead and take my equation and just type it out. It's negative 5x is greater than 30. Now what I want to do is I want to add 5x to both sides because I know that if I move it to the other side, when I move it there, it's going to be positive. So we're going to have negative 5x plus 5x is greater than 5x plus 30. Negative 5x plus 5x becomes 0 is greater than 5x plus 30. So now we're not using the multiplicative property, we're using the addition property. What do I want to do next? I probably want to get that 30 to the other side, away from the x. So in order to get this 30, I'm going to have to subtract it. But if I subtract it from that side, I'm going to have to subtract it from this side. Okay, 0 minus 30 will be a negative 30 is greater than 5x. And by dividing both sides by 5, I get negative 6 is greater than 5x. I'm sorry, not 5x, x. Now we need to put that x in the front. Inequalities don't do me a whole bunch of good unless my variable comes first. So now I'm going to flip it around, keeping in mind that my symbol has to stay open to the negative 6 because that is the bigger part. So x is now less than negative 6. So rather than saying that when you multiply or divide by a negative, just flip the inequality, okay, what we should say is that the multiplicative property of inequality oops, only works with positive values. When we have a negative value, we must use the addition property. And those have been practice problems from Algebra 1, Module 1, Lesson 14, solving inequalities.